Learning outcome 13 is about using the what's called kinetic theory to explain the gas laws that we've just been exploring. So why does increasing pressure increase temperature, or vice versa? And the underlying theory behind this is called this kinetic theory, and we met it at the start of heat. And it's the idea that the molecules, the particles of a gas are in constant random motion, and that random motion gets faster when you increase the temperature, and that random motion causes the pressure because the particles bounce off their surroundings. I stress once again, it's really important that you're talking about collisions with the surroundings here. Collisions between particles don't affect anything. So if we look at the first law, pressure and volume, right? Why does so we've got the idea, remember, that pressure is inversely proportional to volume. I.e., as the volume goes up, the pressure comes down, vice versa. Okay, and we're assuming, remember, the mass is fixed and the temperature is fixed. So if we can explain this, either what happens when you increase the volume or what happens when you decrease the volumes, but I'll go with the decrease the volume. So when we decrease the volume, the particles of a gas basically have less room to move around, so they will collide with their container, their surroundings, more frequently. Now actually that word is quite important. The SQA don't like more often. You've got to say more frequently, which implies more often in the same time. So they collide with their surroundings more frequently. This means they apply a larger force on their surroundings. Remember, we're not changing the temperature, so we're not changing the speed of these collisions, so the individual collisions will still be the same force, but because there's more of these collisions, the total force will be greater. So this means they apply a larger force on their surroundings, and since pressure is force per unit area, so notice we're introducing definition there to justify. So if the force is increased, the pressure increases. Now there might be slight changes in the area when you change the volume. We're going to ignore them and just concentrate on this idea of the more frequent collisions. So that's why when you decrease the volume, the pressure increases. We could reverse this whole argument and talk about when you increase the volume, they collide less frequently, they apply a smaller force. Pressure's still force per unit area and the pressure decreases. So that's the first one done. The next one is pressure and temperature. So remember, second gas law, pressure is directly proportional to temperature in Kelvin. It doesn't really matter for this argument. So when we increase the temperature, remember our definition of kinetic theory says that the particles of a gas will start to move faster. So if not, remember we're keeping the volume fixed in this case, that's the second gas law. But if the particles are moving faster in the same volume, then they will collide more frequently with their surroundings. So basically they're going to get in between the walls more in less time. Okay, they're travelling faster. surroundings more, and once again got to stress, use the word more frequently please, not more often. More frequently, and this is a wee bit different to the last one, because they're moving faster when they hit the walls, each individual collision will apply a larger individual force. So we put those two together. Once again, they apply a larger force on their surroundings. Container you can use there, and you can't just assume that the marker knows this. I know we mentioned it just above, but these wouldn't be in the same question really. So pressure is force per unit area. The pressure increases. So there we started with temperature increasing, and we end up with pressure increases. So we're showing this direct proportion. And the last one is a link between volume and temperature. Now, to explain this one fully, you need to think a wee bit about the experiment, which we haven't really. I don't expect you to memorise it, but the experiment worked was the gas that we were interested was in here, and you had a wee bit of mercury above it, which was what was trapping the gas in. And the law we're trying to show here is volume is directly proportional to temperature in Kelvin. So when we heat the gas, when the gas is heated, its particles have more kinetic energy, will move faster. And they will strike the bottom of the mercury plug more frequently and with larger individual force. This pushes plug upwards because the force in the bottom of it now is greater than the force on the top of it from the air pressure. So that was we were keeping this at constant air pressure. Just investigating volume and temperature. Mercury plug upwards, increasing the volume of the container. So we've got our temperature and volume in direct proportion. And that's the final gas law. It doesn't have to be that exact description. It could be just a balloon, for instance, a flexible container. And as long as you've got that idea of more force, when you heat it, larger force, making the container bigger.